Welcome. Now we are at the step when we would like to use our validation file together with the simulation to compare and see to what extent the model gives some reasonable output. And of course, this is the most exciting things when we are doing simulations. But before we can start to do this, we need to make some issues with our files. So you remember that we created one file, soil validation, that actually contains the information from two different locations, location 3 and location 4. And they were a type of setup with soil moisture and soil temperature and a groundwater level. So they were looking very much the same, but of course if we compare the conditions here, they are not very similar when you, for instance, would like to see the groundwater level. That's called vannhöjde. So it will be interesting to see what will the model do and how will the model compare with those information. And to come to this level, we have our model in the peak inversion XML file. And to open that, we just click on that, and then we can again examine that file. And we know that this file works well with the climate data. And if we now would like to make something that works both for the climate data and the validation data, then we need to prepare a new document. So first I go to model files, and then I see that the meteorological data are location 3, but we decided to create another name. We should have location 3 climate to make sure that this is now only the climate data and the climate data separated from all the other data. So that's what we have here. But now we need to add one more file as model files. And these model files are a validation file. And then we visit the validation tab in the menu. And here everything is now empty, no information at all. If I right click somewhere here, I get some more information. But first of all, we see that 0 validation files are valid. Add new files. And that's what is now most obvious. And I then click on this, and then we will get the chance to specify a file for validation, and that's the soil validation.bin that I had in mind. Then still the sheet validation is quite empty, but once I click it again, you see there are new options, because now one validation file is actually added, but there's no connection between the variables and the different things we are simulating. So then we have something that is called add new TSV validation variable. And if I click on that, then we get a new window showing the variables that I have from the validation, and then showing another window that contains all the variables that we have in the model. So in that way we could now start to make a pairing. So for instance, this jordfusk fukt at 30 centimeter could be compared with any other variable in the model. And of course we would like to find some jordfukt that should correspond to this 30 centimeter. And of course we have water content 1, 2, 3, 4, 5. But how to know which one we should select? This happened to be 30 centimeters and this is different horizons. We can just by chance take number 4 and then we add this and we accept this and we have one pair with the measured jordfusk at 30 centimeter with the water content in layer number 4. If we should find out what the water content in layer 4 represent, then we normally go to this parameter tables where we have the layered structure of the model. So all the model are containing layers and they are based on both what we call measured horizons and model layers. Those model layers are the ones that were with number 4. So I happen to see here that index number 4, layer number 4 is from 0.6 to 0.8 meter depth. So this is not very precise compared to this 30 centimeter that we had. And as soon as I change something here, if I make another structure, then it may not match the one I had here before. So we should try to do something that is a little bit smarter. And to find those smarter ways to compare one horizon to another, we should look to actually partly another concept. And then I go to the switches and then I go to all the switches and then you see the switches are in the different categories. There are many categories and I was first looking to this technical category, but then it came to my mind that the ones I would like to see are in a category additional variables. Sounds similar and it can be mixed. But here in these additional variables we have something that is soil temp sensors or soil theta sensors. This is to install the device that you have installed in the field in the model. So I would like to have those sensors and you will understand what I mean when I open such sensors both for the soil temp and for the soil theta. Because now we have a sensor that we could use for any not horizon that connects to the numerical horizons, but an horizon that connects to what we have in independent. So then we visit parameter tables. We see we have additional variables, of course, they are in the same category, and we have temperature sensors, and we have one such sensor for both temperature and for the theta. Now we know that we had 2, and I changed the 2 for both the ones for the temperature and for the theta. And then we see that those sensors, they have an upper and lower position. So we actually have the chance to say that the device that we are using have a type of sensitivity. It may be very precise at exactly the depths, but it will also be with more, a type of volume from an upper to a lower layer. So I will suggest the temperature was at 7 centimeter. And how precise can they install? I don't think it is exactly 7. I would like to suggest that it is from maybe 0.06 to 0.08. So this is from 6 to 8, and the corresponding for the lower can be maybe a little bit less precise than from 28 to 0.32. So this means that the sensor in the model will look to the temperature in this range, and then it will find a type of mean value that represent the volume that also the sensors are hopefully linked to in the field. And for the theta sensor, it might be another horizon if it is, another type of device. Now I don't know, but this can be changed later on. But the important thing is that I would like to make you familiar with the thinking, so you could put something that is sensitive and that understands also the uncertainty of how you are doing the measurements. Okay, what's the point? The point is that now we have two sensors in the model that could be compared and connect not with a certain horizon. Instead, we could connect it with a certain position that represents the sensor in the model. So I go to this, add new T3 validation, and now we can again look to this jordforsk 30 centimeter, and then it might be tricky for you to know all the names of the model. But the theta sensor has a name that should be found here in the alphabetic list as a sensor. Yeah, here it is. Theta sensor 1, but this was theta sensor 2, because now it was 30 centimeter first, and then we add that, and then we could continue, take also this at 7 centimeter and link that to the one at 1 centimeter. Now it is repeated for another, and if they are the same, then it's not much of meaning, but we can just take this as a demonstration. So it's the ones, and then if we get some difference in the performance, then of course there's a sign that they are not the same. And then we had jord temp 30 centimeter. That could be also the now not the theta sensors, but instead we have a temperature sensor. We should have a temp sensor, it is called. So temp sensor 30 should be added, and temp sensor 7 should be added, and that's it. Then we had Vannhøye, and Vannhøye is the Norwegian, and in the model we do not have Norwegian, we have some type of, I call it Swedish, but in hydrology we have different name for this, groundwater level, and in the model we should look for a name that is called saturation, but I don't find any saturation level. So this seems hopeless. We have nothing to compare with. And we have to find out why the model does not represent this for the moment. But of course we had our location number 3 and location number 4, so we can fill it in the same way for our next location instead. So I go to this jordforsk, and that's the theta sensor that we had here, and that was the theta sensor 2, and that we add, and then we take next, and that's theta sensor 1, and then we repeat that and more, and then we repeat that like this, and finally we take the temperature sensor and that was the 1 at 2, and finally we take this one. That's it, and then say OK. And now we have paired all the soil moisture and all the soil temperatures, and we have compared the model with 2 different locations. But we are searching for the saturation level, and we have to find out why it was not in this simulation that is originating from a simulation on evaporation. So then I go to the switches, and then we look to model structure. And in the model structure we can find a number of different models, and we have one model for groundwater flow, and that was off, so it was not included. So what I have to do here to find a saturation level is first of all to put this on. And if I put this model on and look to this, I will also find a drainage and deep percolation. And then we can start to play with different ways to represent this groundwater, or if you want, lower boundary conditions. I see here that the previous option was no flow in the bottom, and actually the physical drainage equation and the empirical drainage equation were both put off. Then I will suggest that we put this physical drainage equation on, and we could use the Hochhocht, that is the ones that is interesting, especially for how to pronounce it. So now we should have a type of groundwater in the model, and now we should be able to find that in the list of output variables and also in the validation. We go to validation, we again go to this add new TSV times 0 variable, and then we should look for this in the list of variables now. So saturation, yes, here I have it. Saturation level is now recovered from the hidden part of the model, and could be combined with this Vanhöje, and we can do so for both of the different sites. That's it. And then we said OK, and then we have 2 more variables in the comparison. Sorry, I only got Vanhöje for location 4. I missed it for location 3. Then we have to go back. I was probably a little bit too quick. I didn't it's here it is. Now we should have it for location 3 as well. Yeah, now we had. Okay, the mistake was that I compared jordfukt 30 centimeter with this saturation level. That was my issue. And if I have one pairing that does not make sense, we can remove that from our list by right click here and then simple remove this number 14, and then remain those 2 that have the correct representation between a Vanhöje and a saturation level. So this should be more or less everything that is obligatory for making such a comparison. But you also see that there is a number of other fields to fill in. And we have, for instance, relative error and absolute error. You have something called duration, and you have possible scaling of your and there are different index. We skip this now, and we will explain that in another video later on. Instead, we will go back to our simulation document and look into this run info, and we will try to make a new test run similar like what we have done before. And then I just click make single run, and the model has been running, and then it shows the performance of the model comparing the different measured variable with the different simulated, and showing the performance indicators. So if we are interested in showing good performance, I see one particular one. This is 0.73, the temp sensor 2. Oh, that's great. We look to that. That's the simulated value, and this should be the one that is measured. Oh, not too bad. But the magnitude is different, but there are some similarity in the patterns it represents. So, I mean, it's of course not sensitive to try to compare this if we don't know what we are simulating, since we are now just looking into something that we haven't examined. The groundwater level is like this. The red one is the simulated, and the blue is one treatment, and the green is another. So the model have some similarity with both, so it can't be totally wrong, but far away from being something that should be acceptable. I will stop there and say that when we have reached this level, then we have reached the level of technical connecting the model with input and output, and also being able to see how the model behaves. But we haven't been able to understand whether the model represents what we simulate. The only thing we have been looking to is actually that we have a climate that happens to have the same period in time as the ones that are measured, and that the model is, consistently connecting those two together. So the next will be to understand how we can actually make something about the calibration as such, and find a good representation for the simulations.